Hello everyone, welcome to Introduction to Electrical Engineering course. In this lecture, we will discuss about the analysis of pure R circuit. Pure R circuit. So which means when a sinusoidal voltage is applied to the pure resistive circuit, what will be the nature of current, what is the power consumed in the circuit, we will understand with the help of the circuit diagram and phasor diagram and waveforms. So first let us consider a resistor, pure resistor R connected to a AC source of voltage V, sinusoidal voltage V. This V is equal to Vm sin omega t is the sinusoidal voltage, pure resistance R. Whenever we apply a voltage to a pure resistive circuit, there will be current flowing through the resistor. Let us consider the current flowing through the resistor is I, instantaneous current I. This is instantaneous voltage V. V is equal to Vm sin omega t. So, according to Ohm's law, we know that if we have a resistance, if we apply voltage, there will be a voltage drop. Let us consider the voltage drop across resistor is VR. This is VR. So from Ohm's law we know that VR is equal to current flowing I into the resistance R. So V is equal to current into resistance R. So whenever we apply a voltage to a single resistor, whatever the voltage applied voltage, the same voltage will be available across the voltage resistance as a drop. So we can say that the VR is equal to the applied voltage V. So if you substitute these two equations, VR is equal to IR and V is equal to Vm sin omega t, we get I into R is equal to Vm sin omega t. So current I will be equal to Vm by R into sin omega t, and this can be written as I is equal to Im sin omega t. So this is the nature of current when we connect sinusoidal voltage to the pure resistive circuit, where Im is the maximum value of current which is given by maximum value of voltage Vm by resistance of the resistor R. So this is the nature of current. So from this we can say that both voltage and current, V is equal to Vm sin omega t, I is equal to Im sin omega t. So from this we can say that both voltage and current are in phase. In phase means whenever voltage is 0, current will also be 0. Whenever voltage is maximum, current will be also maximum. That is the meaning of in phase. So let us draw the phasor diagram with the voltage and current equations. We know that both are in phase. So let us take up the phasor diagram. Let us consider voltage as the reference wave. This is V. So voltage is the reference. We know that current also in phase, so current will also follows the same path. So this is the phasor diagram for pure R circuit. Now let us draw the waveform of voltage and current. Waveform for voltage and current. Let us consider again voltage is the reference wave for us. This is the sinusoidally varying voltage wave. We are drawing voltage and current waveforms. Since we already know that current is also varying sinusoidally, and let us to differentiate the current wave, let me draw with the help of the dotted lines. Current wave with the help of dotted lines. So this is the current wave. This is the maximum value of voltage. This is the maximum value of current. This is Vm. Here it is Im. Similarly here, negative maximum of voltage and negative maximum of current. So this is voltage waveform, this is current waveform. So this is the waveform of both voltage and current. Now let us calculate the power consumed by the pure resistor circuit. Whenever we apply the sinusoidal voltage to a pure resistive circuit, let us calculate the amount of power consumed by this pure resistive circuit. So to calculate the power, let us start with to calculate the instantaneous power consumed. Instantaneous power in the pure R circuit. This instantaneous power is nothing but it is represented by small letter P, which is equal to the instantaneous voltage into instantaneous current. Instantaneous voltage into instantaneous current. So instantaneous voltage we already know it is Vm sin omega t is the applied voltage into instantaneous current is Im into sin omega t, that is instantaneous current. So from this equation, if you rewrite this, this will be Vm Im sin omega t sin square omega t. So we can apply some trigonometrical formula for this sin square omega t. We get Vm Im sin square omega t can be written as 1 minus cos 2 omega t whole divided by 2. 1 minus, so that is the formula for the cos 2 omega t. If you apply, sin square omega t will be equal to 1 minus cos 2 omega t divided by 2. So upon reducing, this equation can be reduced to Vm Im by 2 minus again Vm Im cos 2 omega t by 2. So this instantaneous power has two terms. One is the fixed term, one more is the variable. So this is a constant term, this is called as constant term, this is the variable term. So this variable term varies with respect to cosine cos 2 omega t with 2 times of the normal frequency. Omega t is nothing but it is the frequency. So omega t is the frequency, it is varying 2 times of the normal frequency. So this is the instantaneous power consumed in the pure R circuit. Now let us calculate the actual power consumed in terms of the RMS value. This can be calculated with the help of the average power. The average power consumed by the pure R circuit is represented by letter P. The formula for calculating the average power is the area of the instantaneous power wave, area of the instantaneous power for one cycle divided by length of the base. So this is the formula to calculate the average power. So we are calculating the average power for one complete cycle. So one complete cycle, the base will be 0 to 2 pi. Base will be 0 to 2 pi. So length will be, it is only 2 pi. It is 2 pi. And area since it is a waveform, we can calculate the area for one full cycle. It will be 0 to 2 pi. We already know the instantaneous power, so if you integrate the instantaneous power with respect to omega t, we will get the average power consumed in the circuit. So this can be calculated as 1 by 2 pi into 0 to 2 pi is the limits. Instantaneous power we already know, that is Vm Im by 2 minus again Vm Im by 2 into cos 2 omega t. It is integrating with respect to omega t. So upon integrating this equation and substituting all the limits, we will get the average power P will be equal to Vm Im by 2. So this can be written as Vm by root 2 and Im by root 2. So we know that Vm by root 2 is nothing but the Vrms value, and Im by root 2 is again nothing but Irms value. So in general we can write the RMS values are represented with the capital letters. So we can write V into I. So this is the average power consumed in the pure R circuit. So from this we can say that in case of the pure resistive circuit, there will be power consumed, and the amount of power consumed can be calculated by using this equation, V into I, RMS value of voltage into RMS value of current. Let us draw the power waveform. Let us draw the power waveform. Power waveform. So again consider the voltage is the reference wave. Voltage is the reference wave. This is the voltage reference, and we know that the current also follows the voltage. So this is current. So instantaneous power, we are drawing the instantaneous power wave. This is voltage, current and P as well. This is with respect to omega t. So instantaneous power is nothing but multiplication of instantaneous current and instantaneous voltage. So for the first half, if you look at both voltage and current, both are positive. So if you multiply the positive halves, you will get the positive power with the peak value will be equal to the both peak values. Multiplication of the both the peak, Im into Vm. So this will be Vm into Im. Again for the next half cycles, it is negative half cycle. Both values are negative. So if you multiply negative into negative, again it will be positive. Again this peak will be again Vm Im. So from this is the instantaneous power P. This is the applied voltage V. This is the current flowing through the R. So this is the waveform for the power in case of the pure R circuit. So this is the analysis of the complete analysis of the when you apply a sinusoidal AC voltage to the pure R circuit. In this video we learnt about the what will be the nature of current and what is the power consumed with the help of the phasor diagram and as well as waveforms. Thank you.